Yeah, so let's go with a rapid fire round. How many of you know what a TCP/IP handshake means?
Transmission control protocol.
Yeah, but what is the handshake? What does a TCP handshake process looks like?
Used to control the process of transmission. Transmission data from it will control the transmission, sir. Whether it is through internet or anything without any
No,
interaction.
that is the no. I get it. That is the nature of TCP, or that's the characteristic of TCP. But more specifically, what is the handshake? What does a TCP handshake mean?
So it's nothing but after the transaction giving an acknowledgement regarding the transaction is called handshake.
After the transaction, what transaction is it? Okay. Okay. All right. What is a port? What is called a port? What is the definition of port? What is the definition of protocol?
Sir, follow the rules, sir. Set of instructions passed by authorities.
Okay, set of instructions passed by authorities. Which authorities?
Sir, any higher authorities in general, sir, not in this. In general, any higher authorities should compulsory to follow this set of rules.
Rules, right? Okay, that's called protocol. Okay, but in the context of computer systems, what is a protocol? You're right. I mean, that's the English definition of protocol.
Set of rules that govern communication between two different devices.
The communication endpoints.
Okay, yeah, that's correct.
What
it's
is
basically
the
a set of rules.
endpoint?
Yeah, so it's basically a set of rules that govern the communication between two different endpoints over a network, right? So that's called protocol. Okay, and you've got, can you guys name a few protocols?
TCP/IP protocol, UDP protocol.
The ICMP protocol, IGMP protocol.
What else?
SMTP, HTTP,
FTP.
Yeah, see, you're all missing a very important one, right? That we use on a day-to-day basis, right? HTTPS. Yeah, HTTPS is one of the most important protocols, right? TCP, ICMP, UDP. Yeah, all these are protocols that we use, right? So even RDP, SSH, they're also protocol, right? SSH is a protocol. RDP is a protocol. Okay, and port, I think somebody gave the definition of port, right? So that's basically the endpoint for communication. Correct. I mean, if you take the literal meaning of port, again, you can consider a port, correct? A physical port that you see, harbor, right? So where ships come, they dock, and then they offload their goods onto, in the harbor, correct? So port is nothing but it's probably a place where you dock yourself and then offload or take import export materials and then communicate to a different country and give it, correct? It's a very similar thing. Just take that analogy, right? Again, here, even in computer systems, an operating system will have ports, multiple ports, and each port is used to communicate with another endpoint, and that endpoint also will communicate over the port. Okay, so you can take a few examples of what a port is. You can just Google for it. Ports and protocols. Yeah, so if you open this Wikipedia article, this explains very well what is a port. Yeah, a port is a communication endpoint at the software level within an operating system. A port is a logical construct that identifies a specific process or a type of network service. A port is identified for each protocol and address combination by a 16-bit unsigned number known as the port number. The most common transport protocols that use port numbers are the TCP and the UDP. Okay, and port number is always associated with an IP address of a host and the type of transport protocol used. Okay, and if you see, there are multiple port numbers from, since it's a 16-bit unsigned integer, it can be from 0 to 65,535. Okay, and you have some standard port numbers which can't be changed, right? I mean, they are reserved port numbers, right? So they are non-changeable, right? So if you see this common port numbers, right? Again, IANA is responsible for establishing these standards. Okay, that every operating system, right? So tomorrow, you know, some of you may actually write your own operating systems, build your own operating systems, correct? So now when you write your own operating systems, you know, you will have to follow these standards, right? So for example, you have to assign port 22 for SSH, right? Port 20 for FTP. You can't assign a different port for FTP. If you do it, then your operating system will become an island. No other operating systems will be able to talk to your operating system. So that way, all these are brought in to encourage interoperability and to encourage openness and to encourage some sort of standardization in the industry. Right? So that's the reason why these are brought in. Okay, so you can just go through this and familiarize yourself with some of these port numbers because these are common interview questions, right? So if they'll ask you, you know, what port the DNS service runs, so it's port 53, and they'll ask you, you know, the EC2 instance is not able to, do a DNS lookup, right? So then they'll ask you which port should you troubleshoot on, and you should say it's port 53. Okay, and 443, right? So 80, 443, right? I mean, if you see 80 is HTTP. Right, all the websites that we see here, if you see here, this is HTTPS, correct? HTTPS is SSL, right? It uses a SSL secure socket layer, HTTPS, right? So it has a certificate in it associated with it. That is 443. So now I am browsing this Wikipedia article that is actually on port 443. So the server which is hosting this web page will be exposing port 443 to the internet. Okay, if it doesn't expose this port 443 to the internet, you know, no one will be able to access this website, this particular web page. Okay, so that way it's important that you understand these common ports. Port 80, port 443 is for HTTPS. So they are called HTTP, HTTPS ports protocols. Okay, all right. So now let's do a bit of, you know, TCP handshake. Okay, so none of you have read about the TCP handshake process?
No, sir.
No? Okay, then probably this will be an assignment for you today. Okay, so read about these. See, these are, I would say, elementary. Correct? This is like probably you are in kindergarten, right? Kindergarten, you learn the alphabets, ABC, and if you're learning other languages like Telugu, Hindi, Tamil, right? So you learn the basic alphabets, right? Syllables. So it's like that. So you'll have to, you know, come what may, learn these. Okay, there's no other escape route. Otherwise, you won't be able to clear interviews. Let me be very, very clear, right? So the basic interviewer would ask you if you apply for a systems engineer, software engineer role, or even for that matter, cloud administrator role. The first question that will be asked is, explain about the TCP handshake process. Okay, so it is important you learn these. Okay, so now what happens is let me give you a basic intro to that. I'm not going to go too deep into this because this itself will take probably a few hours to explain, but I'll leave this to you. You can learn this by yourself, but I just want some of the follow-up learning that we are going to do in today's session will need you to understand the TCP handshake process and the way the protocols and ports work in a computer networking. So now, see, we live in a client-server world, correct? I mean, that's the distributedness of this industry that we are living in today, correct? So we are no longer, I mean, if you see, take 60s, right, 50s, 60s, when computers were invented, networks were not there, right? So there were no networks, or there were very limited networks. I mean, a computer would be a standalone, isolated, siloed thing. And, probably a computer a server would take a huge room, okay? And the room would be filled with full of computers, or rather one computer, not full of computers. It will be just one single computer. Right? So that's the way computers were there. And it was all one single machine. And that single machine would run commands, processes, and that will also have a input output device associated with it. And if you need to use it, you have to physically go to that place, sit in front of that computer and start using it. It's a single terminal, correct? Whereas, when the form factors became better over the years, and there was a lot of invention to build personal computers, where Microsoft, IBM, Apple, they pioneered the invention of personal computers. Then the whole concept of client came into picture. Okay, a personal computer is just a client, right? You're using your personal computer as a client to accomplish many activities, right? So to browse websites, right? To watch movies, to watch videos, right? To play games, right? And so on and so forth, correct? So that's where, if you see, the client server concept came into existence. But earlier it was all only one. Both the client and server would be on a single box. But then the client came out of server because of the inventions in the personal computer space. And then came the whole concept of protocols, like TCP protocol was invented. So, and TCP protocol became the standard de facto for communication in the client server world. Okay, so now you have servers, right? So servers are everywhere, right? I mean, servers are, in fact, I would say clients are everywhere, right? I mean, each one of us are using a laptop or a desktop, which is a client, or we are using a mobile device, which is a client, or we are using a tablet device, which is a client, correct? Or we are using a connected device, which is a client, correct? I mean, when I say connected device, it could be a small microprocessor or some sort of a device which is embedded in my car, right? Or which is embedded in my washing machine, or which is embedded in my AC, or even fan these days have got a intelligence in it, right? IoT. So now each one of them is a client. And what is a server? Server is a one which actually serves the needs of multiple clients, right? So for example, I'm browsing this website, Geeks for Geeks is a website that I'm browsing. So now this would be hosted somewhere in some server on some infrastructure somewhere, right? I don't know where it is hosted currently, but it's hosted somewhere and it's available over the internet. So now my client, which is this laptop from where I'm browsing, this browser from where I'm browsing, needs to establish a connection with the server, which is geeksforgeeks.org, and it needs to browse this web page. So when it needs to browse this web page, it needs to establish some sort of connectivity to that server, correct? And the server will have some identity, the client will have some identity. It will establish some sort of a connectivity to that server. That process is called, and the protocol that it uses is TCP protocol. Okay, TCP is a very standard protocol, pretty much used in any communications. Okay, so that process is called the TCP handshake process.
Sir,
Okay,
this
so
is
now,
like a DHCP DORA process.
no, so DHCP is different. DHCP is called Dynamic Host Configuration Protocol. Yeah, but what's your question?
DORA process, right? Like DCP DORA
Yeah,
process,
correct,
like
correct. DORA
half-range
process.
request.
Exactly. This is something like TCP DORA process, but DHCP DORA process. But DHCP DORA process is used for a different purpose. Okay. Whereas TCP handshake is used commonly. If you see 99%, you will be using TCP handshake for anything at the end of the day. Okay. So now this needs to perform a handshake between a client and the server. You take any communication in the internet or any communication for that matter, a communication always happens between a point A to point B. Okay, that's the way communication happens. Probably there could be hops in the middle, multiple hops in the middle, but at the end of the day, after going through all the hops, it is the communication between a point A and the point B. So the client knows that, okay, this is the server, and the server knows that this is the client that is trying to access its resource. Okay, remember that. So now from that perspective, the client will have ports associated with it, because as I said, a communication happens between a port to the port, right? You take the harbor example that I gave. When a ship comes from Singapore, say to India, it will originate from a port in Singapore, from a specific dockyard in one of the ports, right? And it will originate from there. It will carry goods, come to a harbor, say in Chennai, and then it will dock in a particular port in Chennai harbor, and then it will unload the contents, correct? So port is very, very important. So port is the place, a physical point, which initiates communication and terminates communication. Okay. So from a client perspective, the client should have ports, 3 ports, so that it can establish TCP connection. On the server side, the server should also have some ports which it will be listening on. That's called the service ports, which will be listening for communication. It will always keep listening for communication. The moment some communication comes on that, it will take the communication, it will start processing that data. Okay, so now the process that takes to establish this handshake, right? It's like this, correct? Say I'm meeting a stranger. Okay, I'm coming across somebody, a stranger. And what I'll do first, right? So first I will introduce myself to him. I'll tell him about myself, my name, what I do, and so on and so forth. And the stranger also would give details about himself, right? His name, demographics, and so on and so forth. Right. So then we handshake. So that's called the handshake process, the physical handshake that we do. So then once I know about him and he knows about me, then we can actually start sharing information, right? For what I mean, the reason why I met him or he met me, we can actually start sharing those actual information, correct? But before that, probably that handshake is required, correct? So it's similar way, right? Here also, right? A client is going to talk to a server. The client will initiate that handshake process. Server will also acknowledge that handshake process, and then it will finally, once the server is convinced that the client is a genuine client, so then it can start establishing the TCP process, right? So from that process, there are 3 stages in that. What the client does is it first sends a packet. Okay, so now before that, I also will give you one more assignment for today. Learn what is a packet. Okay, so learn what is a packet. So you will see some network packet, right? Use this Wikipedia article to learn what is a packet and how packets are different, etc., etc. Right? So learn about it. It's very simple. Nothing, no rocket science. Okay, and also learn about TCP header. Okay, so TCP header, right? So learn about TCP header. What does a TCP header contain? I'll give you all of this. You can read about it. See, it will look abstract, but the moment you apply it practically, you will be able to appreciate it. So it's not like something which is not used, right? It's just for the heck of it. No, these are important, right? So this is how the header looks like in a TCP protocol. Okay, it has got a source port, destination port, sequence number, acknowledgement number, some reserved bits for a few handshake activities, checksum, and actual data. Okay, this is what it will TCP port will contain. So anyways, I mean, going back, so it will first initiate, it will send a SYN packet. Okay, it will first send a SYN packet. SYN is nothing but it's basically to synchronize, right? To synchronize the communication between these. It will first send that SYN packet to the server. Then the server will append that SYN packet with an acknowledgement packet. It will send it back. So then the client will take that acknowledgement packet and then send it back to the server. So that way the handshake is established between the client and the server. So if you see this is host P, this is host Q. Host P is first going to send a SYN packet with some sort of a sequence number. It will be a random sequence number. It will send it to this guy. This guy will receive it, and then he will send the same SYN packet, which will have a sequence of x+1, which is y, and acknowledgement. Right? It will send it to this guy. This guy will receive it, and then what it will do is it will take the acknowledgement packet and then it will append it by 1 and it will send it back to the server, and that's how the SYN ACK. Right? So these are the 3 steps in the entire process. There are a lot of videos. Don't worry, there are a lot of YouTube videos. Open one of those and watch those videos. They will clearly explain, what is the process involved with this. But in interview, expect one question around this. What is the TCP handshake process? What is a port? What is a protocol? Okay, and what are the common ports, common protocols? What is HTTP standard port 80, HTTPS 443, and the standard port for SSH is 22. Standard port for FTP is 20. Okay, so these are certain things, certain basic things that you need to understand. Okay, so now let's get to the topic for today. Okay, so now what we want to learn today is three topics: shared responsibility model, security groups, and NACLs. But I'm not sure if we will be able to cover NACLs today. Let's see if time permits. Let's cover. Otherwise, we'll keep it for tomorrow. But security groups definitely we need to cover today. It's a very important topic. And shared responsibility model. Okay, so now before we jump into the security groups, I want to introduce you to something which AWS does. It's called a shared responsibility model. What is the definition of responsibility? Can somebody answer?
To take care of something.
Perfect. To take care of something. Okay, and to basically own that activity, right? To own that piece. And I'm owning something, so it's my responsibility to ensure that I complete it, or rather I be 100% responsible for that, right? So if I build a data center of my own, who's responsible to secure that data center? Someone answer. If I'm owning, right? I'm Prasanna. I am
You
owning.
are responsible, sir.
I am responsible, right? So perfect, right? I mean, I cannot ask someone else to come and own the responsibility, correct? All right. So I need to ensure that I secure my data center. I build enough systems and controls in place and put controls in place so that it is secure enough. All physical controls, armed guards, security, intrusion detection, prevention systems, and everything, correct? And similarly, even the physical premises of the data center, right? Like have access control systems. And in order to protect the data center safe from fire, floods, I have to ensure that I have enough systems in place, alarm systems in place, fire alarm systems in place, fire suppression systems, like the ones that you see, right? In malls or offices you go, you'll have the sprinklers on the top. So those are fire suppression systems, fire alarm systems, right? All of that, it's all my responsibility end to end, correct? But imagine, I don't want to build a data center, right? I want to go to cloud. In cloud, whose responsibility it is?
The cloud provider's responsibility.
Okay, what is cloud provider's responsibility? I mean, of course, don't look at this diagram. This is obvious. But what is cloud provider's responsibility?
To secure the data and store the data properly.
To secure the data and store the data
take
properly.
care of the data centers.
Okay. So again, see, these are some of the loose definitions, right? So when you say secure the data and store the data, it's very loose, right? I mean, it does not qualify very clearly who is responsible for what activity, specifically, like what activity, who is responsible for what.
The cloud providers are responsible for the integrity, confidentiality, and they are also responsible to restrict the access only to the owners of the data.
No, that's not correct.
Customer satisfaction, sir.
So no. So integrity, data confidentiality, all of that is your customer responsibility. So this is where, okay, let me come to this. Okay, let me come to this topic, right? Yeah, thanks. Yeah, thanks for all those responses. But see, this is where most of us, have a misconception that who is responsible for the security of the data and things like that, correct? So now in AWS, we have something called a shared responsibility model. So that responsibility is there, right? But it is shared between both AWS and also the customer. In this case, customers, all of us are customers of AWS, right? All of you are customers of AWS. Right? So you're spinning off an EC2 instance, you're storing something in S3 bucket, you're hosting a database, you are a customer of AWS, right? So now what AWS has done is they have very clearly demarcated what is AWS responsible for and what is customer responsible for, right? So if you see this diagram, the orange box, the bottom portion. Can you please go on mute? Somebody is on unmute. Yeah. So now if you see, the bottom orange box is where AWS is responsible for. The top one, the blue, is where the customer is responsible for. They're very clearly demarcated. So now what is the definition of AWS responsibility? Responsible for the security of the cloud. So the overall cloud security, right? That is AWS responsibility. So now let us delve deeper into what is AWS responsible for. So in this case, the regions, availability zones, edge locations, right? So these are all physical regions, correct? So the physical region, for example, in Mumbai, there are multiple availability zones. In Hyderabad, there is a new region which is going to come up. So now the physical premises of that, in terms of, nobody should be able to get into the data center. In fact, I was showing you the video the other day, right? So there were armed security guards outside AWS data centers, correct? So that is AWS responsibility. You don't have to worry about paying salaries to that armed security guards, who are protecting the physical perimeter of the security. And to enter into the data center, you need access, correct? And not everyone has got access to enter into the data center. And there are access control systems which are closely guarding the access in the data center, correct? And you don't have to manage those access control devices. Okay, so now and you don't have to pay for those access control devices, or rather you don't have to manage the license life cycle of those access control devices, right? And once you get inside, to get into the actual core data center and to access a rack or access a server, you don't have to worry about that, correct? And there are administrators, the operations team, they take care of it. Okay, so that entire physical security, the physical access, all of that is taken care by AWS, right? So that's what you see as hardware or AWS global infrastructure. So even the hardware, right? What hardware can go inside the data center? What hardware can come out of the data center? And what type of hardware can be placed inside? You know, all of that is AWS responsibility, right? Even the securing those racks, right? Individual racks. So each rack will have a key, right? I mean, so to secure those racks, it's all AWS responsibility. It's not your responsibility. And if you go one more layer above, right? Compute, storage, database, networking. See, all of these at the end of the day, they're all physical hardware stacked in the data center, correct? And probably one piece of that is given to you when you provision an EC2 instance from that. Right? But having said that, they all reside within the data center in the form of some sort of compute, storage, database, and networking, correct? So this is the layer that AWS manages. AWS has built the fabric that AWS built to manage the entire infrastructure, correct? Such as AWS has built this whole console, correct? The console that you see, where you go log into the AWS console, go to EC2, provision an EC2 instance, and you authenticate before that using your credentials, right? So all of that is actually running in some AWS infrastructure, correct? So all of that is managed by AWS, and you don't have to manage that. I mean, if there is, you don't have to really worry about what is going behind that console, AWS console, how AWS is authenticating. All of that is managed by AWS, right? And software, right? Any software that is used to secure the cloud infrastructure, right? Say such as like the virtualization, right? The virtualization layer itself, all of that is managed. You don't have to worry about all of those. So now, what is that you need to worry about is the blue part. From the bottom most, it is the client-side data, right? So for example, you provision an EC2 instance and you use a key, right? I mean, we all provisioned a key yesterday, correct? A PPK or a PEM file. So now it is your responsibility to secure that key. AWS will not bother about securing your key on your behalf, and AWS also will not ask you for that key. Okay, they will not say that, oh, no, give me that key, I will keep it safe. No, AWS will never do that, because security is job zero in AWS. And what AWS does is they will not breach any customer's trust through, a leakage of data, or to take that responsibility on them, right? So they have very clearly demarcated that is your responsibility, it is customer's responsibility. Say tomorrow you provision a key and you lose that key, it is your responsibility. AWS will not own the responsibility. So similarly, you provision an EC2 instance and you store some data inside that EC2 instance, some confidential data. It is your responsibility to secure that confidential data within the EC2 instance. AWS will not worry about that, because see, the moment AWS takes up that responsibility, then it becomes their headache, correct? So then requirements will be varied, right? And then in this case, as a cloud service provider, they won't be able to, and I as a customer do not want my cloud service provider to peek into my data, to take a peek into my data. I don't want them to do as a customer, correct? And none of us would want to do, right? The same thing applies to even some of the cloud storages that you have, right? I mean, when you use a cloud storage, I mean, you store the data in your cloud storage. The cloud provider will not have access to your data. Okay, probably the underlying infrastructure they will have access to it, but the moment they get into the infrastructure, they won't be able to access your data, because that is tightly controlled by you, right? Server-side encryption, right? Any encryption that you want to do, that is your responsibility. Any traffic protection encryption, like for example, you can host a website on an EC2 instance by HTTP. It can be plain on HTTP, right? But if you want to secure it, you have to add a SSL certificate to your website to make it HTTPS, so that the end-to-end communication is encrypted and no middleman can take the data and view that data. Operating system, right? So when you build a EC2 server on AWS, that operating system becomes your responsibility, right? When I say operating system, you need to manage the life cycle of that operating system with respect to patching, right? So when you buy computer, when you buy a laptop, the laptop comes with some operating system in it, correct? Windows operating system. But what Microsoft does is they launch updates to the operating system every once in a while, every month, right? And then they pop up saying that you have an update. So whose responsibility it is to update that operating system? Once you buy your laptop or desktop, you have to do it, right? I mean, Microsoft is not going to come and do it, correct, for you, correct? The user's responsibility. So same thing here also, when you provision an EC2 instance, you have to patch it. You have to ensure that the network and firewall configurations are made appropriately, where you are securing your EC2 instance. So that is the topic for today. How do you secure your EC2 instance in terms of network communication? So that is where you use security groups. And then any applications that you run on top of it, any IAM that you do on top of it is all your responsibility. And ultimately the data, the customer data, what you store inside EC2 instance or inside any cloud service that AWS offers is your responsibility. AWS will not take the responsibility of your data. So be very, very clear about it, right? It is your responsibility, and there are multiple layers of security that you want to have, right? I mean, you have your house, you have an apartment, right? I mean, you live in an apartment. The apartment will have, it's a big complex, maybe 10-floor apartment complex, and there are say 100 flats in the 10 floors, right? So now, there is going to be a common security in the apartment, outside the apartment, right? At the gate, you will have some common security, but it is your responsibility to secure your flat, correct? Because you need to have a proper door, lock and key. And if you want to install CCTV cameras, you can install CCTV cameras, right? And you have to secure your valuables in a locker within your house, right? Within your apartment, within your flat, correct? I mean, you can't leave it to, the building administrator. That's correct. So it's a similar way. So the customer data is your responsibility. Okay. So now let's get into security groups, correct? What is a security group? I'm going to close all of this. Okay, so you've got a VPC, right? So VPC is basically a logical construct that gives you a virtual private environment for you to deploy your cloud resources, correct? So now in VPC, you've got something called security groups, right? Which will act as a virtual firewall. What is a firewall, by the way? Have you heard about this term firewall? Have you used any firewalls? Have you used the firewall in your Windows operating system? It's a Windows operating system comes with a default firewall, right?
Antivirus, some kind of.
Sorry?
Antivirus software, sir.
No, not antivirus. Antivirus is different. Antivirus is for malware protection. But what is a firewall?
Use it to restrict unauthorized files applications.
Okay. So, so now time to apply our learning, right, of ports and protocols. So now you have a server, and the server has got multiple ports, right? I mean, you can open a port, you can actually install something on a particular port, and the clients can listen to that, and the server will be listening on that port, and clients can connect to that port, correct? So now imagine you don't have a perimeter, right? You don't have a perimeter security for your operating system or your server. Okay, it's like this, right? So you have okay, let me go back to my apartment example. So you're actually buying a flat in a gated community. It's a huge venture. It's a huge gated community. There are, say, 10 towers in that gated community. So when I say 10 towers, then 10 buildings. Okay, each building is 15 floors tall. Okay, so now let's take, you've bought one flat. of probably 2000 square feet or 1500 square feet. Okay, so now what will your flat have bare minimum? It will have 4 walls, correct? Bare minimum it will have 4 walls, right? So that 4 walls is the one which is protecting, or which is basically demarcating that this is your flat, correct? And that 4 walls are the ones which are protecting your space, correct? And also that 4 walls is the one which is protecting any access coming into your apartment, correct? So now further you have the main door and you have a back door to your apartment, correct? So the main door ensures that that's the only entry point to get into your apartment, correct? You don't have any other entry points to your apartment, but you have only the main door as your entry point to your apartment, isn't it? And you can enter into your apartment unless and until you have some sort of access to your main door, right? You have a key, right? And you can enter into your apartment, enter into your flat, correct? So now similarly look at it even in the context of a server, right? A server is running and you want to stop all unauthorized access to the server. So you build 4 walls around that server. Okay, so that no unauthorized access is made into your server. But you also have to allow some traffic to flow into your server, right? If you block all the 4 walls, so then it's done. All the communication will be cut, right? For example, imagine a flat with just 4 walls, no entry point such as door or windows. What will happen, right? It's completely cut off, right? So you have to allow some traffic to flow into the server. So that is where you form small doors into your server, on the walls of your server, saying that okay, so and so traffic can enter through this, right? And you may actually have so now you have you have bought an apartment, you have bought a flat which is probably about 3000 square feet, a huge one, with a intent of converting half of that into an office, right? You want to actually run your office from that, run your business from that. Okay, and half of that will be your living space, half of that will be your office. So now what will you do? You will form, like, say, 2 doors, correct? Or 2 entrances to your apartment, right? So one entrance is for your living space, one entrance is for your office space. Okay, so now you will demarcate, saying that any person visiting your home will enter through this door, or any person visiting your office will enter through the other door, right? So you're basically segregating the traffic, saying that okay, this traffic coming through this will enter through this, the other traffic will enter through this, right? So that way you're segregating this entire. So similarly, even in server, you will have a firewall. In this case, the firewall is a security group in AWS, right? Any EC2 instance that you take can have will need to have a security group, because that security group is the wall, right? So without the wall, you can't build an apartment, right? You can't build a flat. So those are the 4 walls of your server, and within the security group, you form small doors for a specific type of traffic to enter into your server and gets processed by your server, right? So those are called ports and protocols that you define. Those are called rules in a security group. Okay, and those rules are nothing but the rules that will define what are those door entry points for your server, right? And that rule will define what server can, what protocol can it communicate on, what port it can communicate on, and what is the source, right? And in this case, I may also want to say that I mean, I have, in my apartment example, I have 2 doors in my apartment. One is for my living space, the other one is for my office space, right? So now for the living space, I may want to restrict that, only certain people may enter through that. I don't want anyone and everyone to enter through that. Whereas for my office business space, I may want to give a slightly unrestricted access. Anyone can visit my office because it's my business, correct? Whereas for my personal space, only a few people can enter through that. I want to whitelist, saying that only say 10 people can enter through that, and I may probably have some sort of access control or some, biometric access or whatever it is. Okay, so please go on mute. Somebody is on unmute. Okay, so that's what I want to achieve, right? So the same thing applies in security group as well. So when you take a security group, what is a security group? A security group acts as a virtual firewall for your instance to control inbound and outbound traffic. Okay, both inbound and outbound traffic to the server or from the server. When you launch an instance, a VPC, you can assign up to 5 security groups to the instance. Security groups act at the instance level, not at the subnet level. Ignore this for now, right? So, I mean, there's the reason why they say not at the subnet level. You will learn about this later when we speak about NACLs. Therefore, each instance in a subnet in your VPC can be assigned to a different set of security groups. Okay, so now what is the group basics of security groups? In security group, you can only specify allow rules. You cannot deny. Okay, you can only say only so and so traffic can enter through this. You cannot say if a specific traffic comes, it will deny. Okay, that explicit deny rule is something that you can't do in a security group. You can only do an explicit allow. By default, anything other than the allowed will be denied. Okay, it's like this, right? So you have a biometric system outside your door, outside your living room door, and you only whitelist say 10 members or family members to allow through that biometric system. So only if they place their thumb impression, they'll be allowed access to enter through that door, right? It's like that. Whereas anyone else comes, even if they try, they won't be able to enter through that. Okay, and then you can specify separate rules for inbound and outbound traffic, right? So for example, you can allow traffic for those who are possible to allowed through the inbound, and you can also specify rules for outbound. And in security group rules enable you to filter traffic based on protocols and port numbers, right? So you can say that specific protocols and specific ports are allowed, right? And security groups are stateful. Okay, this is a very important thing, but very tricky thing to understand. So when I say stateful, if you read the definition, if you send the traffic from your instance, the response traffic for that request is allowed to flow in regardless of inbound security group rules. Okay, so responses to allowed inbound traffic are allowed to flow out regardless of outbound. Say for example, if you allow an inbound, okay, say on port 80, okay, you don't have to specify that in the outbound, right? By default, outbound will also allow port 80. Okay, so similarly, if you allow some traffic to go out, that is also considered as inbound. So this is where you need to understand some ephemeral ports that are there, right? I'll also learn about that ephemeral ports. In fact, I'll come back to that later. When you use a TCP/IP handshake, especially in web servers, they use something called ephemeral port. The ephemeral port is used to establish n number of connections from a web server. Okay, but for now, remember that if you allow something inbound, that is also allowed for the outbound. Okay, you don't have to explicitly mention that. When you first create a security group, it has no inbound rules. Therefore, no inbound traffic originating from another host to your instance is allowed until you add inbound rules to the security group, right? So now one more thing, correct? When you basically buy an apartment, and when you want to install some sort of access control, initially it will be by default, it will have nothing, right? No rules, right? Then you have to start defining the rules, saying that, okay, who can come in to my apartment, right? So it is your responsibility to define that who can enter into your apartment. Okay, you can't allow each and everyone, right, or everyone to enter into your apartment. So you will basically, or into your office, so you can only specify that only a few people can enter into my apartment. So those are all rules. Or you can also allow anyone, right? So that's up to you, right? But initially, when you buy an apartment, nothing of these sort is defined. Then it is your responsibility to define people who are entering into your premises. Okay, people may walk out of your premises. That's okay. People who have entered can walk out. That you may allow freely. You don't want to restrict them, saying that okay, you have entered now. You only stay here. This is a jail for you. Okay, that happens only in probably a prison, right? Nothing, nowhere else. But in in your apartment, if you allow people to enter in, they may walk out freely, right? But you may have some restrictions in inbound. So that's what I'm trying to say. Always, when you build systems, you need to have control in terms of what clients can talk to me, what systems can interact with me. So you may want to always secure your inbound, right? So wherever you go, right? I mean, you go to a probably some sort of okay, you go to a passport center, right? Apply for a passport. There's going to be a security guard outside, scrutinizing your entry, right? Or you go to any other government establishments, there will be a policeman, who will be scrutinizing your entry, correct? So that's basically and they'll check. I mean, why are you here, right? I mean, if you are there for for not a specific purpose, then they won't allow you inside, right? So they'll say, I mean, if you walk into you can't walk into a CM's office, correct? Just like that, or into secretariat, right? So it's like that. So they have protected their inbound entry points very well. So similarly, in your server also, you have to protect your inbound entry points very well, so that no unauthorized access can breach into your EC2 instance, right? So that's what your security groups allow you to do. But once you come in, you can just walk out, right? I mean, once you go into, say, a CM's office after taking all approvals and after your work is done, right? You want to give some petition, you give that petition, and then you walk out. So when you walk out, nobody is going to ask you, right? They'll just allow you to freely walk out because it's not their responsibility. From there, you go out. It's you go to any other place. That's not their prerogative to ask you where are you going from here, right? So they can walk out freely. So that means that you may not have restrictions for outbound. You may have free restrictions for outbound, but the traffic that is flowing outbound, say for example, from a specific EC2 instance, you are making a connectivity to another EC2 instance. That other EC2 instance B should have a clear inbound rules saying that what traffic can come in. Okay, that's the way it usually works. Okay, so now and usually the security groups are associated with network interfaces, but for now you don't worry about network interface. When we speak about EC2 instance, you will know what network interface, but for now understand that a security group is like a firewall guarding your EC2 instance for all inbound and outbound traffic on specific ports, protocols, and IP addresses. Okay, so now let's go back and look at what security group is. If you go to the EC2 Explorer, EC2 console, on the bottom you will see network and security, and then the first one that you see is a security group, right? So when I click on security group, there are so many security groups, but let's create a new security group. Okay, this is a new security group I'm creating. Okay, but before that, let's also just see if there is a small video on EC2 security group. Okay, so let me just play this video.
Hi, Lata. Hi, Deepa.
Now we are ready to get an introduction to security groups. So security groups, they're the fundamental of the network security in AWS, and you'll hear them more and more and more. They control how traffic will be allowed into your EC2 machines, and as such, they're super important. So we have the WW, so the nets and the EC2 machine, and our security group, and basically we'll control the inbound and the outbound traffic. It's honestly the most fundamental skill to learn to troubleshoot networking issues in AWS, and if you understand security group, you understood a big part of the Amazon cloud. So in this lecture, I want to show you how to use the allowed, inbound, and outbound ports just to get you a feel of how things work. So let's get started. Okay, so we have our EC2 instance, and as we can see, the inbound rules of our security group says that port 22 is allowed. So if we go into our terminal and we add a session to it, it works. Great. But what happens when we start messing around with the security group? So you can click on it and you are taken directly to the security group page. By the way, on the left hand side, you can quickly get back to it under network and security. So we have a security group and it has a name, it has a description, and we have inbound, outbound, and tags. Now under inbound, this is all the rules that will allow traffic into our EC2 machine. And so by default, there's no rules, okay? And we have to add rules. And the rules we've added when we created the EC2 instance was this SSH rule. If we go to outbound, by default, all traffic is enabled out of the machine. And so that means that the machine can communicate everything everywhere. This is fine, by the way. Finally, tags is if you want to add a name tag or whatever you want for your EC2, for your security group, but this is fine, we won't play with it. Now, what happens?
Yeah, so if you see this right, so initially he was explaining about this, correct? This is the World Wide Web, internet, or any, I mean, it could be any other system in the network, correct? Security group is the one which allows inbound traffic, controls inbound and outbound traffic. So let's just come out of this. Let me go back to my EC2 console. Before that, let me just go back to this little whiteboarding. So you have a VPC, you have got two subnets, public and private subnets. You've got IGW. All of this we are familiar with it, right? I mean, we are now masters in this. This red box that you see is the security group that is securing your EC2 instance. Okay, by default, it is mandatory to attach a security group to the EC2 instance. Okay, if you create an EC2 instance, you can't create an EC2 instance without associating a security group to it. That security group can be a blank security group with no access, or it can have some access. Okay, so now let me go back to the security groups. I will create a small security group here, simple security group. I'll say it is my EC2 or let me make it more meaningful. Public EC2 instance security group 1. Public EC2 security group 1. Here I'll give a description to the thing. This is security group to allow traffic on public EC2 instance. Which VPC I want to use this in? I want to use this in my my VPC. Okay, so now here you will have two sections, right? Inbound rules and out. By default, there won't be any inbound rules. By default, all traffic on all protocols, all port ranges to all destination is allowed. Okay, it's like this, right? I'm living in my apartment, right? I mean, you know, I may walk out freely through my apartment, right? Or even when you go to say any offices, I mean, people can once they visit the office and they can walk out freely. Nobody's going to stop them, right? So the same concept applies here, right? So from your EC2 instance, you can freely access any resource on the network or on the internet. But you want somebody accessing your resources, you will be more mindful of that, right? You will be more mindful of who can access your resource, right? Who has the authorization to access your resource, right? So you will basically be more worried about the inbound rather than the outbound. So that's the reason you have outbound rule as all traffic, all protocols, all ports, and the destination is custom destination, right? It's just 000. So I said that 0000 is all. Okay, anything. Okay, it means that any IP address will fit into the 0000 range, right? It can be any IP address whatsoever, right? Be it a public IP address or a private IP address. You take any IP address, it fits into this range of 0000, which means that this is like everything. This is like universe, right? Which contains everything. So 0000 is like the universe of IP address. Okay, so now I don't want to restrict any. So the moment you say all traffic to 0000, which means that you don't want to restrict any traffic. You want to allow outbound to go from your EC2 instance to anywhere. But inbound can be specific, very specific. Now, if I click on add rule, so now here I will see the protocol or the type, right? These are some of the predefined types that AWS has pre-populated here. So it has got multiple things, right? It can be a ICMP. ICMP is nothing but your ping, the ping that you use that uses an ICMP protocol. If you go for SSH is on TCP protocol, port 22 is SSH. If you use SMTP, that is port 25 is SMTP, which is your mail servers. Similarly, HTTP is TCP, port 80 is HTTP protocol. HTTPS is TCP, port 443 is HTTPS. RDP, right, which we are using to connect to Windows, that is TCP 3389. Right. Similarly, SQL Server 1433. Right. These are all reserved ports, right? So which are taken by standard protocols and some of the standard software vendors like Microsoft SQL Server, MySQL, Oracle 1521, right? So that's what it does. So, but anyways, let's go here and let's select SSH here, right? SSH is TCP port 22, or you can also do custom TCP and you can say port 22. You can change this port number, right? And I want to basically allow 00. Anyone can access my EC2 instance through this port 22. So that is the first network security layer, right? And that is the first network security layer that I want to allow. Or if I want to allow only say one IP address, I can specifically give that IP address with a /32, which means that it specifies only that one single IP address, right? Again, go back, CIDR.xyz. Right? If I say what is my IP, see, this is my IP 49.37.168.121. See, if I make it /28, then it means a big range of 16 IP addresses, right? But if I say the /32, it's that one single IP, which is 49.37.168.121. That's it. So that is how you give a notation for a single IP address. It is always /32. So then you have to give /32 here. Okay. Or you can make it 0000. Okay. So now I can make it 0000. Okay, and I'll show you. Maybe we can do some small examples out here. Right. I'll say that allow SSH on port 22. Okay. Similarly, I'll also add one more rule for ping. I will say, yeah, I'll make it custom IPv4. I'll make it all IPv4, all ICMP IPv4. For now, I'll just make it 0000. Allow ping from the world. Okay, I've done this. I will just create the security group. Okay, cool. The security group is created. It's called public EC2-SG1. Okay, so now let me go to EC2 and let me launch a new EC2 instance using that security group, which is a Linux A2.micro, my VPC subnet 1, because I need internet access on this. so that I can demonstrate this to you. Next, add storage. Next, add tags. Add a tag here, name, public EC2. Okay, next, when you click on next, sixth step, right, which is configure security group, that's where it will ask you to either create a new security group or select an existing. We have already created a security group. I will simply select this, select an existing, and I will look for my security group that I want to choose, right? So which is that is public EC2 SG1. So this is the security group. It shows the rules. Okay, it shows the rules, the inbound rules, which is port 22. The ICMP, right? The ICMP is ping. Let me just review on launch, and I will use my kp.pem. Okay, I acknowledge and launch instance. Okay, it's going to launch the instance. Let me select that, and if I come down on the details tab, I have a security tab here. So the security tab, you can see which security group is associated with it, what are the inbound rules and what are the outbound rules. In this case, inbound rules are all ping traffic and port 22 from source anywhere. Okay, 000 means anywhere. Outbound is it allows all traffic to go out to any destination. Okay, no restriction on the outbound. When you see this, it means that no restriction whatsoever. It's open, free access. Whereas inbound is not free access. Inbound is restricted only to this, only for ping and only for SSH. Okay, so now it is running. Okay, so now let's do one thing. Let's pick up the public IP address of this. Open SSH. Okay, let me open this, and let me say SSH -i mykp-pem.pem ec2 user @ my public IP address 13.127.222.43, right? So this should work for me, right? So because I have a rule in my security group that says allow on port 22 from any source. So this uses port 22, SSH uses port 22. Okay, so this allows traffic from port 22 on from any source, right? You can also use telnet to test the connectivity, right? So telnet is a small utility using which you'll be able to test the connectivity. I'm not sure if I have a telnet installed. Yeah, telnet is there. Okay. Yeah. So you can do telnet -t22 so telnet is a small utility. So I mean, these are also important internet question interview questions. Okay. Telnet example. Okay, so you give the IP address and then the port. Okay, fine. So give the IP address and then on port 22. So this is just to check whether the connectivity is there or not. See, it's connected. It says it's connected. Okay, I can come out of it. Just press Ctrl+C and come out of it. But if I give a different port, right? If I give port 222, it won't, because it's not allowed. And nothing is listening on that also. There's nothing listening on my EC2 instance on port 222. And port is also not allowed through my security group. Okay. Whereas if you try it with 22, it immediately connects. Okay. So anyways, let me go back and I'll say enter. Yeah, it allows me to connect. Yes. Okay. So now let me come out of this. I'll say exit. And I can also do a ping 13 to 127 to 20 to 43, right? Okay, so now all of you can do this from your open. If you're a Windows user, you open a command window, and I'm just going to give you the command. Just try this. Ping 137, 113, 127, 222 41. At least a few of you can try and let me know if you're able to get a response. Are you getting a response?
Yes, sir.
Yes,
You're getting
sir.
a response, correct?
Yes, sir.
Okay, cool. So now let me get a little adventurous here. What I'm going to do is I'm going to go to my security group. Okay, let me open the security group in a new tab. I'm going to make few modifications to the security group in the inbound rules, where I will edit my inbound rule. For ping, I had given 0000, right? So that's why all of you are able to access it. Okay, at least a few of you who tried were able to access the ping. Let me remove this and just let me make it only my IP address. Which is, what is my IP address? My IP address is this 49.37.168.121. I will just give only my IP address, but I have to give it a slash in the CIDR notation, which is /32. Okay, I will just give it and then I will save it. Allow ping from the world is gone. Allow ping from me. From Prasanna alone, right? So I'll just give that. I'll save the rules. I have saved it. Now try the ping. Guys who tried it earlier and it was working, can you try now?
Like we are getting timed out, sir.
Timed out, but it is working for me. See? Okay, it's working for me. So whoever got a timeout, can you tell me your IP address?
Yes, sir.
Yeah, tell me.
Sir, my IP address.
So mine
Just
is
go to
45,
what is my IP in Google and get your IP.
45.115.89.186.
186, right? /32. Okay, I'm also adding your IP address. Oh, sorry. Yeah, please repeat it. 45 dot
115.89.186.
So now yours is also added. Okay.
Sir, my IP address is 49.
One sec. Sorry, one sec. Let me just add a new rule itself. /32. Yeah. What is yours? Tell me.
49.37.
49.37 dot
156.88.
I don't know why is it not accepting to add it to the existing. Okay, let me do one thing. Let me remove mine and add one of yours, right?
Sir, it accepted.
156.88.
Sorry, sir, to interrupt. It accepted,
Yeah.
sir. Extra IPs will come next to it.
But I don't know, some problem with the UI. It looks like it was not displaying the second IP. But anyways, I don't know, probably offlate the few UI related issues that are coming up. Anyways, I've removed mine. So whoever had, 49, 37, 156, 88.
Yes, sir.
Right now.
That's mine. Okay, sir.
You're able to ping, right? Yeah.
1 minute, sir. Yes, sir.
You're getting
Now
a
it's
response,
coming.
right?
Yes, sir.
Yeah, so that's how it works, right? So that's how a security group works, right? So now you can clearly see. In fact, what I can do is, in fact, I see that this 49 range is, even if I want to kind of whitelist a complete range, I can whitelist a complete range, right? So for example, I can give 49.0.0.0/16. Yeah, see, I think it was it Prashant. Prashant, if you see, it is actually replacing the older one with this. Okay, anyways, so you can also whitelist a complete range of IP addresses through this. So, but anyways, I mean, the whole idea is, are we able to restrict access to certain sources to communicate on certain ports and protocols through IP address or through the security groups on both inbound and outbound? Okay, so that's very important. So there's actually a lab session for today that I want all of you to do, right? So one is knuckles, we will come back later, but for now, this is actually not 2nd, this is 3rd December. Yeah, 3rd December, just save it. Yeah, so read about these, right? Apart from this, I'll also give you a few more things, right? A few more, I don't know if I mentioned the other ones here. TCP handshake process. I will leave it to you to choose, whichever. I mean, pretty much all the definitions and examples that you see are valid, but you can watch some videos. Okay, Wikipedia articles on ports, protocols. Okay. Yeah, so use the public EC2 instance that was created the previous lab exercise. So create a new security group named public SSH access all. Create an inbound rule as below, right? I mean, you can use your public IP address by Googling what is my public IP, and you can add your public IP here and click on save rules, try to SSH from your PuTTY to the EC2 instance. And you can add another rule for ICMP, add another rule for ping, this is ICMP. And once you add the other rules, you will get the all the rules here. Click on save, then try to ping the public IP of the EC2 instance. And remove the all ICMP rule and try pinging the EC2 instance. The ping should time out. Okay, so this is the exercise that you will do today, right? And once you complete it, as always, go back, go to instances, and what are you supposed to do?
Terminate the instance.
Terminate. Yeah, perfect. Do that. Okay, that's one. And more importantly, I also want you to take 1 minute to kind of review the billing dashboard on a daily basis. Okay, it will give you insights into how much bill have you incurred, right? I mean, you can check this, right? You can check your billing dashboard and check. I mean, this pie chart that you see will tell you what is your current bill. I mean, don't worry about this number, because as long as you're within the free tier limit, this will get nullified at the end of the billing cycle, right? I mean, as long as if you're within the billing limit, but if you exceed it, this will get charged to your account. Okay, so you have to do that and ensure that you go ahead and terminate your EC2 instance. I've terminated. So ensure that you use these resources very frugally so that you don't have to pay for these. Okay, but the responsibility is yours, right? As I said, shared responsibility model. AWS is not going to worry. Because for AWS, you are a customer. Okay, I'm going to give you this. Sorry, was there a question?
No, that's
Yeah, so I've shared the assignment for today with you. So let's complete it. And then we can start NACLs tomorrow. NACLs is another extension of security groups. I would probably put it that way. I mean, from a learning perspective, but NACLs are even more powerful than security groups, and it gives you a firewall at an entire subnet VPC level. Okay, all right. So I will. Yeah.
So once we have configured the VPC, subnet, and routing tables, and we have not created any EC2 instance and leave these two days, then AWS apply the charges or not?
So if you create just a VPC,
subnet,
security
routing
group,
tables,
there is no charges for any of those resources. Only when you provision an EC2 instance, your meter will begin.
Okay, sir. Thank you.
Okay. Yeah. Okay, fair enough. So I'll let you all continue, and we can try and complete NACLs tomorrow, or tomorrow can be Linux, right? So we can, as I promised Saturday, I'll spend time on Linux, right? So we can learn about the basics of Linux and basic Linux commands. We'll do that tomorrow. Okay. All right. So all of you got the assignments, right? You have it in the chat window. So please get into your breakout rooms and start building on it, and wish you all a wonderful day. See you tomorrow. Yeah. Thanks, Sai Krishna, Sairam. Thanks, mentors. Bye, Sairam.
Thank you, sir.
Thank you, Anna, Sairam.